Hello everybody, welcome back to my class. Today I'm going to continue with central angles and inscribed angles. So first of all, I'm going to start with solving the last homework. We have this circle that is centered at A, and I have the angle CAD that measures to 51 degrees, and you're asked to find three measures. Let's start from the arc CE. All right, now we said that the measure of the arc is equal to the measure of the central angle. So what is the measure of this central angle? It is 90 as shown here plus 51. So this in total is 51 plus 90, which is 141. Now the length or the measure of my arc will be the same and will be equal to 141. What about DF? The arc DF, we know that this angle in total is 180. I'm talking about the angle CAF. It is 180, right? Because it's a straight line or a segment that passes through the center. The measure of this angle here, I'm talking about the angle DAF, is equal to 180 minus 51. That is 129. So the measure of this angle here all is 129. Now this is the measure of my angle DAF. So what is the measure of the arc DF? It is equal to the measure of this angle, and it is equal to 129. Finally, I'm looking for the measure of the arc BEC. BEC, what is it? The angle BAE is a straight angle. That means it measures 180 degrees. Now this angle 180 plus 90 plus 51 gives me this total angle here. Alright, what is it? It is 180 plus 141, which is 321. So the measure of this angle here is 320. So the length or the measure of my arc BFC is equal to the measure of the angle BAC from this side, the big one, which is equal to 321. Now let's start a new topic. We call an intercepted arc. It is an arc that consists of these 2 points that are within the inscribed angle. Example, AB. We call this arc AB is an intercepted arc because its endpoints A and B are lying on the sides of an inscribed angle, which is D here, or ADB. Now, if I have an intercepted arc and the inscribed angle is ADB, then the inscribed angle theorem says that the measure of my angle ADB will be equal to half of the measure of my intercepted arc. So if this angle here is 40, the length of my arc will be half of this, which is 20. So MADB equals half of the measure of the arc AB. What can you say about this? Previously, we said that the length of the arc equals to the measure of the central angle. Is it? Yes. So my central angle, let's say ACB, will be also equal to the double of the inscribed angle, that is ADB. Clear? Let's get this example. I have this circle here centered at C, and I want to determine the measure of the arc DE, which is here, DE, and the measure of the arc BD, which is from here, BD, all of this, the measure of the angle DAB, DAB, which is marked here, and the measure of the angle ADE, ADE, which is here. Now, what I'm given here is this angle, that is EAD, that's 54 degrees, and I'm given 18 degrees, for the arc BE. Now, how can I find DE? The arc DE, okay, it's an inscribed angle is EAD, right? So we said that EAD is half of the intercepted arc. So the arc will be twice as this angle, which is 54 times 2, which is 108 degrees. So the measure of my arc ED is twice as the inscribed angle, which is equal to 108 degrees. Now, what about BD? BD. From the addition postulate of arcs, the measure of the arc BD is equal to the measure of the arc BE plus ED. I've given BE, that is 18 degrees, and ED was already calculated in the first step, which is 108. So BD is 18 plus 108, which is 126. Clear? Now, let's go to the angles. The angle DAB, where is the AB? DAB. How can I find it? It is DAE plus EAB. So this total angle is equal to this one plus the small one. Let's look for the small one first. Now, look, this is an inscribed angle. It has this intercepted arc, that is 18. My inscribed angle from the previous theorem says that it is equal to half of this arc here, so it is 18 divided by 2, which is 9 degrees. So if this is 9 degrees, this is 54 degrees, then the total is 9 plus 54, which is 63 degrees. That's one way to find it. There is another way, actually. Look, for the angle DAB, it's an inscribed angle and its intercepted arc is BD, so it's half of BD, and we already found that BD is 126, so my measure of the angle will be half of 126, which is 63, which is the same answer. Let's go to the last angle, which is ADE. ADE. What is this measure of this arc? AE. We can say it is 180 degrees. Why? Because the central angle ECA is a straight angle that is equal to 180 degrees. We said that the measure of the arc equals to the measure of the central angle. So this total arc here, AE, is 180 degrees. Now, I'm looking for the angle ADE, which is an inscribed angle. So from the theorem, ADE will be half of the intercepted arc, which is 180 divided by 2, which is 90. So this angle here, in fact, is 90 degrees. Clear? Let's give you here a general remark. Whenever you have a triangle like this, and one of its sides, for example, this one, is a diameter of your circle or passes through the center, then it is a right angle at the vertex that is in the circle here. All the time, whenever you have a right angle here, then also the hypotenuse of your triangle is passing through the center. All right, let's solve another example. Let's find the measure of the arc WX, this one here, WX, and the measure of XZ, which is this one, and the measure of the angle XWZ, which is marked here, XWZ, and the measure of the angle WXZ, WXZ. All right, let's start from the arc WX. What is the measure or the measure of my WX? Look, it is with this inscribed angle that is WZX, right? And it is intercepted arc. So the length or the measure of my arc is equal twice as the inscribed angle. So it's 9 times 2, which is 18 degrees. What about XZ? XZ is equal to what? The measure of WXZ, this total arc, okay, equals to WX plus XZ. Now, this one here is 180 degrees because I have a straight angle here. So, XZ is 180, which is this total, minus the arc WX, which is 18. So, my arc XZ is 180 minus 18, which is 162. All right, let's go to the angles now. The measure of the angle XWZ, this angle here, what is it? It's very easy. It will be equal to half of my intercepted arc. The intercepted arc is 162, so the angle XWZ is half of 162, which is 81 degrees. Clear? Now finally let's go to the angle WXZ. WXZ. Wow, this is very easy. Now, by just simply looking at this arc here, WZ, we can say it is 180 degrees. All right. So it is an intercepted arc and it's corresponding to this inscribed angle. And the corresponding angle, we said it's half of that, so it's 180 divided by 2, which is 90 degrees. So this triangle, in fact, here is right at the vertex X. Clear? Now, look, in the same example, I wanted to find the measure of the arc XZ in a different way. So remember, in the previous one, we found XZ from saying that it is 180 minus 18. So we took this 180 minus this arc here, which is WX, that is 18, and we said it's 162. Is there another way to find this arc XZ? Yes. Let's see. Now, the measure of the angle WXZ is 90 degrees. Why? Because it's an inscribed angle and it is intercepted arc here has 180 degrees, so it will be half of that, so it is 90 degrees. Now this is 90 and the sum of this triangle angles is 180. We know that. So this is 9 This is 90. So this should be what? 180 minus 9 minus 90, which is 81. So the angle here, XWZ, measures to 81 degrees. Now, the arc XZ is an intercepted arc, so it will measure twice as the inscribed angle. So it will be 2 times this angle, which is 2 times 81, that is 162, which is the same as the result we found here already. Let's take another example. Now, how does the measure of ABD, the angle ABD, compare to the angle ACD? Now, by looking to this shape, we see that these two angles, they are having the same intercepted arc, that is AD. Since the measure of each angle will be half of the length or the measure of this arc, so ABD will be equal to the angle ACD. So in general, whenever you have any angle that shares the same arc with another angle, these two angles will be measuring the same. If I have, for example, a point here, let's call it F, so the angle AFD will have the same measure as the angle ACD, the same measure as the angle ABD, and so on, as long as they have the same intercept arc. All right, final example. If the measure of EDF is 15 degrees, the measure of the angle EDF, this small one, is 15 degrees. Let's find the angle ABE, which is this big one. How can I find it? EDF and EBF, and EDF inscribe the same arc here, which is EF. So they should have the same measure. ABF is equal to half of this arc, which is AF, that is 44 degrees, and this angle here, ABF, is 44 divided by 2, then this is 22 degrees. Now, what is the angle ABE? It is ABF plus the angle FBE. We previously said that FBE equals to FDE, and it should be 15, so this small one is 15, and we found this to be 22, so the total is 22 plus 15. ABF plus FBE gives you ABE. So 22 plus 15 is 37 degrees. Alright guys, don't forget to check classroom.google.com if you have any questions regarding this class of today, or you try to solve the same examples with another way. Again, the ways I'm showing here, they're not the only ways to solve your problems. It's just a suggested solution. You may have more than one solution for that. If you tried them with different solution, you can share them through Google Classroom. Have a nice day and see you tomorrow. Thank you.